does take time to make this figure based on the information given, and I try to at least draw these out so that they're a little bit to the scale so that it's easier to see the answers. Now, the easiest way to do this question is that if we just look at that 120, then we know this angle here would be half of that. And that means that this angle is 90. And then in a cyclic quadrilateral, which means it's an inscribed quadrilateral in a circle, the opposite angles are supplementary, which means if that's 90, this one has to be also 90 because they need to add up to 180 degrees. And that's the angle we're looking for, BCD, which is 90. So that's the easiest way to do it if you kind of know these two results that I used. If you don't know the fact that the opposite angles in a cyclic quadrilateral are supplementary, then your approach is that once you figure out that this is 90 degrees, and we know ABCD, this is a 90 degrees, so if I connect D with B, this has to be a straight line because this is your half a circle, meaning this has to be a diameter because, again, the property we're using is that if you have one of the sides of a triangle that's diameter, then this angle has to be always 90 degrees. That means that's a straight line. This is 90, then this will also be 90. Essentially, we have two right triangles where BD becomes the diameter. So you can also use this method. Either way, the answer is 90.